All right. Okay. It's Friday, week 4 Friday. So happy Friday, you guys. And it's also Data Fest is starting this weekend. Are you guys signed up to participate in Data Fest? Yes, no, maybe? I don't know. Okay. Well, um, that's all right. Well, I think it's a lot of fun. I'll be there. Okay, yeah, some of you are signed up. So yeah, I will be there, and I think I'm acting as a some kind of advisor slash mentor or something. So I'll be available. I'll have kind of an office hours session for anybody who will be there. And that's gonna start right after this class. So we gotta end, and then we'll head over to Data Fest. But anyway, for today's lecture, I wanted to just kind of show a couple things that you can do with Python. And this is all about kind of working with files in Python. All right. And so we'll just go ahead and take a look. As always, I've pushed today's content onto GitHub. And so you can do a git pull upstream main, and that should pull everything to your directory there. All right. Okay. So this kind of touches on this concept of persistence, which is kind of the idea that, after you do something in Python, maybe you want to store it and work with it later. Okay. And so far, kind of all of these things, even if you run a notebook and you save everything in the notebook, when you start the kernel the next time, okay, your kernel's going to start all over again, right? And perhaps, within your previous notebook, you've generated some data, or you did some kind of analysis, or you created some objects, and maybe it's you can just rerun the entire notebook, and you'll be kind of where you left off. But it's also possible that in your notebook, some of these commands perhaps take a very long time to execute. So if it was up to you, you would rather not have to rerun every single line of code, and hopefully, you might want to just be able to load up a certain file that has, some of the variables and things like that, so you can kind of pick up where you left off without having to rerun all of the previous code. Okay, so the notebooks are handy and you can save them, but certainly when you restart a kernel, or you start a new kernel, or reopen it later, all of those things are gone, right? And so here we're going to talk about saving data to files, and opening, loading data from files and things of that nature. Okay. And so here you can open a file using open. Okay. And this is just part of base Python. And this is going to basically open, what's kind of a session, like a writing, kind of a connection to this file. Okay. And you can specify inside open an argument for W to be able to write to the file. You can open a connection to a file, and you can make it read only, where you're only going to be absorbing data from it, or you can open a connection and have it write to the file. Okay, so here we're going to just say, open something file name.txt, and we want it a writing connection here. Okay, and so if this file exists, then what this command will do is it's just going to completely wipe out the file, right? If it doesn't exist, it's going to create the file. There are options. You can create options to say you don't want to wipe it out, but you want to append, you want to add new lines to the bottom of it and things like that. Okay, so so here it's going to create some file output.txt, and let me get to that. Okay, so here's output.txt. This command, when I run it, it's going to, well, I'm not actually running it right now. This is this is just rendering slides here. Okay, but what this is going to do is it's going to write this line. Okay, or here's the line. The line is just this string here, and we're going to say file out. Okay, so file out is this connection, and to that connection we are going to call the .write method. Right, so the connection is the connection to this output file, and we're going to call the .write method, And it does this, and it's done. And basically, this 32 basically tells you how many characters were written to the file. So it says 32 characters were written to the file. Okay. And if you want to write another line, okay, you just call file out and you call the write method again. And so here we write, this will be the second line of text .n. Perhaps it's more interesting. Let me go ahead and I will restart the kernel and clear everything. So I'll go ahead and come right here. So I'm going to create a new, so I'll let you just see. So here's kind of like my existing file here. So let me just close that. And here I'm going to open a connection here. And let me see. So this wipes out the file. And then I'm going to run this cell, okay, and it writes the first line of text to the file. And so let me go ahead and open that back up. Oh, you know what? I have to close the connection before this gets output. Okay, so we'll write that. We'll write the second line of to the file, and right now the connection is still open. So you have to actually close the connection, fout.close, and that will close out the connection. And that will update the lines of text. Okay, that will when you close it, it will kind of save the file and create it here. Okay, so you kind of continue doing this, and then when you're done writing, you close the file, and so you kind of close that connection. All right, and so closing the file frees up the system resources to track the file, and if you forget to close it, then Python's garbage collector will automatically close the collection, right? So if you do that, okay. You can also use the keyword with, okay? And what with will do is it will kind of open up the connection and it will run all of the commands. And as soon as those commands are done, it's going to automatically close the connection for you, okay? So here you can kind of do with, and you kind of open the connection here. So you're going to open the connection, open output.txtw as file, write line 1, write line 2. You know what? I'm going to go ahead and just do file.write. This is line number 3, exclamation point. Okay. And I'll go ahead and I'll run that. And when it's done, it closes the connection, and therefore the file is updated. Okay. You can also change this to be a read connection. So rather than a write connection, you can say read it, and then it's going to go through each line in the file and then read it in. And it says this is the first line of text, this is the second line of text, and this is line number 3. Okay, so it just kind of reads that in. All right, before I forget, because I totally forgot last class, let me give you your first view quiz answer. First view quiz answer is E. E as in elephant. E as in elephant is your first view quiz answer today. All right. When you use the write command or the write method, whatever you pass to it has to be a string. So when you're kind of writing to a file, it's expecting that you're writing strings, right? And so, you know, to kind of convert anything that's not a string into a string, you can just wrap whatever object you have and wrap it with string. Okay. And then, and if you don't do this, you're going to run into some problems, right? So here I've got X, this is the number 42.3. And if I say Y is equal to 42.3 plus this, and we're trying to concatenate this, it's going to complain. Okay. Here, you know, we can just do, all right, let's turn this into a string, and we're going to do this, and we're going to print that, and this is no problem. Okay. Now, when you convert things like numbers, floating point numbers or integers or whatever to strings, you also have the ability to format stuff. Okay. And so you have the format operator, which is used kind of in the place of strings, and it does some format operations here. Okay, and so there's something called a format sequence, and you should definitely use the reference here, okay? Because there's just a lot of kind of like a way too many things to memorize, okay? Probably the most important ones are just D for basically numbers, okay? And F for floating point, although G is a little bit, maybe a little bit nicer, okay? So G comes after F. All right, so basically G will tell Python to format the number as a floating point number, but if it's like really small, it's going to use scientific notation basically. And F will just kind of preserve it as a floating point number. Okay, and so the way you run this is, so %D will turn it into an integer. So here's this number, 12.34 is X. And basically you have a string and it says %D is my favorite number. And basically what we're going to do is we're going to replace the %D with this number. And the way we specify that is you have the string, %D is my favorite number. You use the % operator after this, okay, after the string. And then you put in the variable that contains the number that you want inserted here, okay? And so we're going to, so X has the value 12.34. So %X says, take that number 12.34 and insert it into where the format operator is and put it in this format. %D says format it as an integer. And so 12.34 basically gets turned into an integer and then a string, and we get 12 is my favorite number. If you do 12.34 and you use %G, then it says, you know, kind of keep it as a floating point number. And then we're going to get 12.34. All right. So sometimes, you know, as you're reading other people's code, you'll see kind of this thing where you see like strings and then you see a % and, you know, some variables and you're like, what's going on there? Basically what they're doing is they're inserting the variables into the string so that it can be printed or written to some kind of file. Okay. There's a bunch of other stuff you can do. All right. So here's just an example of how %G handles the floating point numbers. So if I have 0.0001234, okay, I don't know whose favorite number this is, but it's going to print it out as 0.0001234. Okay, but here if I have a few too many zeros, 0.0001234, then it's going to %G will take that and convert it into kind of exponential scientific notation. So it says 1.234 times 10 to the negative 5. That's my favorite number. Okay, I have my doubts. Whereas %F just kind of preserves it in this form. Okay, 0.0001234. And by default, Python uses 6 decimals of precision when kind of formatting these things into numbers. So you're going to get 0.000012, 0.000012. Okay. If you want to format so it keeps more decimal places, there's a few things. And again, you kind of have to just read the reference. You probably have to go online and just say like, how do I format this in Python? And you'll find some resources online. But you know, you can specify .10, and this basically says keep 10 decimal places after the dot. Okay, keep 10 decimal places after the dot. And so here it says 0.000123400, and that's going to put 10 decimal places after the dot and print that out. Okay. I think for the homework, you know, that you're going to turn in, you know, I saw some questions about, you know, how to, you know, do we need to put in like a leading digit and stuff, especially for like the time operator, right? Like, you know, if it's like 7 minutes, can you just do :7? And how do you do stuff like that? There's a few things you can look it up in terms of like leading zeros for numbers and strings. You can right justify things. So so things line up on the right side and specify how many characters total we should have. There's a few options. Just you have to look up Python format string online, and you'll find a whole bunch of different articles out there. Okay. You're not going to be able to memorize everything. I mean, maybe if you do this kind of stuff every single day, you'll remember some of it, but I don't remember anything. I go into Google and I type, you know, how do I do this Python, etc. Okay. You can also, with the format operator, you can provide a tuple of variables and have multiple kind of format placeholders, right? So here I've got X 12.345, age 85, and I have a string with two placeholders. I have a %D and a %G. So I'm going to say my age is %D and %G is my favorite number. Okay. And then I have the % operator, and then I give it a tuple of variables. So my age is 85. Age gets put into the first operator. So, you know, and then X gets put into the second value here. The second value in the tuple gets put into the second value, second placeholder in there. Okay. And this gets formatted however you want. Okay. I mean, and if you don't know how to, don't remember to do this, you can always kind of just use, you know, my age is this, and then just kind of do plus along with the string applied to, you know, whatever values you have. String on age, string on the number, and, you know, you'll get the same result here. Okay. But I think this is a little bit cleaner. It's a little bit cleaner if you're familiar with this. But again, as you're reading other people's code, if you've never seen this before, this looks weird, right? This looks kind of weird, but this is just the way Python handles, like, how do you insert variables into strings? And this is Python's solution for it. Okay. And, you know, if you want, you can, here's a tuple with 3 values. %S kind of keeps it as a string. Here you have a variable with a string, and it's just going to pass Joe Bruin straight into this position here, 100 into this position, and 83 into this position. I guess Joe Bruin, when was UCLA? 1919. Joe Bruin's now what, 102? I don't know how long Joe Bruin's been around, but okay. There we go. All right, file names. Okay, so you can actually access file names in your own computer using the OS module, okay? And so you can kind of interact with resources on your machine, files on your machine using the OS module. So let's go ahead and take a look. You'll have to kind of import OS. So you do import OS, and you can do a few things, right? So one is you can get your kind of your current working directory. And so this could be useful if you want to kind of just like a script for yourself, if you want to just make sure you're executing a file from a particular directory. So in my case, I have, you know, I store all of my teaching files for this class in this directory name, which is the same name as my repository. And I have it structured. I use, you know, OneDrive. I have a teaching folder, 21 for stats 21. Okay. Yeah, I don't preface my classes with stats because all of my classes are stats. So, so I can just use a number, and it's always going to be a stats that class. Okay. If you want to know where a certain file is located, you can use absolute path, okay, versus a regular path, right? So here we've got the file output.txt, and I could say, what's the absolute path of this thing? And then it says, oh yeah, it's in this output.txt. We have these double backslashes just because Windows uses backslashes for its file to kind of structure the files, and those are like escape characters, so you have to escape them anyway. Okay, so we have that. Okay, and then, you know, just like everything else, make sure you check the reference. There's a whole bunch of stuff. Okay, you can check kind of environmental variables. You can change directories and all kinds of stuff. Just a couple other things that we'll take a look at. You know, you can see, does a certain file exist? Okay, so you can say, you know, does this particular path exist? And you can get either a true or false. So output.txt is a file inside this directory. So that one's a yes. Okay. You can ask if something is a directory. Okay, is output.txt a directory? No, it's a file. Okay, whereas inside here I have a directory called .git. Okay, and that one is a directory. Okay, so a few things that that you can kind of check, but again, consult the reference manual. That's going to generally give you more stuff. All right, we're going to, if you want to kind of just list off all of the contents of your directory, so you can do os.list directory of your current working directory, CWD. I think I specified right here. My current working directory is kind of the string that is my current working directory. So you can say, all right, list off everything in my current working directory. And it lists off all of the file names. All right, and so it just gives me a big list of all of these things. All right, when you're working with files, a lot of times you'll run into errors. Okay. Oh, let me give you your second view quiz answer. Second view quiz answer today is D as in dog. D as in dog is our second view quiz answer for today. And the first one was E as an elephant. All right, so especially when dealing with files, you'll run into a lot of errors just because files might not exist, or you might have another file open by another program. And if a file is opened by another program, usually your operating system will lock it so that it can't be written and things like that. So, if you've ever tried to like knit a file in R while the file is open, you run into an error because it says, I can't edit, I can't write to this file because, it's kind of locked in place and things like that. So, so to kind of handle this, you can use the try and except statements, okay? And they work a lot like if and else, except try is kind of like do this. And if it doesn't work, the except is if it doesn't work, do something else, okay? So here we're gonna try to create a connection. And I'm trying to create a connection with bad file, okay? And this just doesn't exist, right? So normally we would open a connection to something like, we would write like output.txt would write or something, but here bad file doesn't exist. So it gives me an error. It says no such file or directory. And that's fine. You get an exception. That's fine. But if you want, to kind of clean things up, you can put them into these blocks and you'll say try, and it's going to attempt this line. And if it does it, then great, it's going to just keep going, okay? But if it doesn't work, then you have the except block and it's going to run this line, okay? And it's only going to run the except block if this thing runs into an error. If this thing doesn't run into an error, it's just going to move on to the next thing, okay? It's going to skip the except block and then just move on to the next part of the code. So here we would write something went wrong because this thing couldn't open, right? And it's a handy thing. So Python first tries the commands in the try block. If everything goes well, it skips everything in the except block. And if it encounters an exception, if it encounters some kind of error, it's going to exit the block and run whatever's in the exception block. Okay. All right. So now we can talk about a couple things. We've got DBMs and we also have pickles. And these are ways for us to kind of store things onto our hard drive for later access. Okay. So a DBM it's a lot like a dictionary, okay, but you're going to save it to a file, all right? So first you have to kind of import the DBM library to get access to this functionality. But this is just part of the standard Python library. And so you don't have to install anything else. If you have Python installed, this is part of the standard library. Okay, so you're going to call dbm.open, and this is going to open this kind of database connection, all right? And a lot of times when we hear database, we think like SQL and all sorts of fancy stuff, but this is just like a basic Python database, which is effectively a dictionary, okay? It's effectively a dictionary, okay? All right, and so you're going to open a kind of a connection, okay? And so here, we're going to kind of create the captions database, and it's going to create this file captions.dat. Okay, and if it what this C does is it will create it if it doesn't yet open. Okay, and again, okay, and so here you can specify a few things, right? So one is the default is just for kind of reading, and then you have W for writing, and then C is going to be for reading and writing and creating if it doesn't exist. Okay. All right, and then you would just kind of add keys just like a dictionary. Okay, so here we have this is kind of like captions for different photos, right? All right, and so we're pretending we have some kind of somewhere else. Maybe we have a this is the key cleese.png. Okay, that's just an arbitrary name, and then we're going to give it the value photo of John Cleese. All right, so this I'm taking from the Think Python book. This is the example from Think Python, and the author is a big fan of Monty Python. Or maybe he's just using Monty Python because the language name Python. Who knows? Okay. So anyway, John Cleese is in a lot of Monty Python stuff. Okay. And so here the key is this string cleese.png. All right. It's not a file. It's just a string. Okay. And the value is another string. Right. And then later, if we want to retrieve, the value, we use it just like a dictionary. We call, here we've created this database connection. And we can say, well, what's the value inside this this thing? The db cleese.png comes back and it says, the value there is photo.png. Okay. And so here's another key value pair. Jones.png gets this thing, and we get that. All right. And then just like before, we can kind of iterate through some kind of sequence. All right. And we can just go for every kind of key and what's the value there. Okay. And we get all sorts of, a little bit of weird stuff, okay, attached to it. And it says inside our database, we have kind of these keys. And what is this? This list with kind of a memory address, right? And then we'll close it here, okay? And then, when you create it, it's going to create basically the captions.data file, which is not really intelligible. Okay, it contains some stuff, right? It's got photo of John Cleese, but then a whole bunch of other things, okay, that we can't really make sense of. Okay, the back is a something else here. Okay, these are kind of the key names, right? And I think this is the position in which, I don't know. This is just how Python stores the information. Okay. So I think this is the key information, and I think .back is the backup of it. I'm not quite sure. And the .dat kind of, where is this? This is in position 512. I don't know, something. Okay, who knows? Index position there. All right, so it just kind of stores this stuff there. So anyway, these files all get created, and this is just how you can kind of store information in a dictionary-like structure for Python, but have it be kind of this permanent resource on your file that you can then, if you want to access from, like, say, a different notebook, right? So if you have multiple notebooks or multiple files and you want to kind of access the same kind of dictionary, you can create a Python DBM and gain access to it. Okay, and then the other thing, and we'll finish a little bit early today. The other thing that we can create is a Python pickle. Okay, and so one limitation of the DBM is that it can only kind of store strings or byte objects. Byte objects being basically just some basically text type information, right? If you wanted to store other types of objects, such as you wanted to store a list, or you wanted to store an entire dictionary or something else, you can create you can pickle them. Okay, so it's kind of like the idea of, like, I don't know, if you want to store food for later or something, you can pickle the food and it will last a long time, I guess. I don't know. Okay, so anyway, what pickle does is it's going to kind of convert your file into basically a string object. Okay, something that looks like a string that can then be stored in the DBM, right? So the DBM is only allowed to store strings and byte type objects. And what Pickle will do is it's going to take this other data structure and basically convert it into, a sequence of strings and stuff that we can then work with. Okay, and so here, this is effectively, this is why we're seeing kind of this list here. But so here, I'm creating a small list, okay, with the values 1, 2, 3, okay, with the values 1, 2, 3. And if I call list here, and if I say, what is this? This comes back as a list, right? Here, I'm opening up the database connection. And if I try to, the DBM connection, if I try to just store this object T directly in here, I get an error, okay? It says, you can't do that, right? You can only do this with string objects, byte objects. It says you're not allowed to just take a list. You can't just store the list in the DBM, okay? So what we have to do is we gotta pickle it, okay? So we call import pickle, and then what we wanna do is we're going to call pickle dump, okay? Or pickle dump S. Dump S turns it into a string, okay? Okay, so you have dump, and dump S is gonna basically turn it into, I guess, a bytes type object, sorry, but basically like a string, okay? So it's gonna convert it into something that looks like a string. And so this is what it looks like. So when you take this thing, just a list with the numbers 1, 2, 3 in it, and you turn it, you call dump S on it, it's going to turn it into this, all right? And this is basically a string representation. This is unintelligible to humans, but it's basically a string representation of what that list was, okay? But now that we have it in this form, we can say, all right, take S and store it into DB, okay, under key list, okay? So we do that, and then we'll close the database connection, all right? And so now that's what we have stored in here. When I look at the caption database, we've got, well, it's like impossible to read. Okay, but it's stored in there, okay? So now that we've pickled it, we can retrieve it, okay? So we can say, all right, open up the database, right? And retrieve list, right? And so when you retrieve the list, you get back this. Again, unintelligible, we can't do much with it. But then what we're gonna do is we're going to convert it using pickle load, okay? So you have pickle dump and pickle load, all right? Or dump S and pickle load S is basically what we're doing, okay? So we call pickle load S, and it's going to restructure whatever this thing is. It's going to say, all right, what is that? Okay, let's turn it back into the original structure, and then it turns it back into the list. And so now we can use it, okay? And so that's a handy feature, right? So if you want to store something, you've got one notebook, you've got some files or objects that you've created, and you want to be able to retrieve them or access them from another thing, you can kind of transfer them and access them from another notebook by using the pickle and storing it into a DBM. Okay. You can also pickle objects directly to a pickle file. Okay. And you can kind of group them all together. All right. So here we have object 1, object 2, and object 0, 1, and 2. All right, object 0 is, one list, object 1 is another list, object 2 is a string, okay? And what we're gonna do is we can just kind of create a pickle pickle file, objects.pickle, okay? And then we're gonna tell it to write in binary mode, okay? So when you do, where did my Python? Okay, so we're going to tell it to write in binary mode. That's what the WB stands for. Okay, so we're going to say write in binary mode. And then what we're going to do is we're going to do the dump directly into the pickle file. Okay, object 1, object 2, object 0, object 1, and object 2 into this. Okay, so pickle.dump is meant for storing the files into a pickle file, whereas pickle dump s is meant for storing things into kind of your DBM file, which requires string type data. Okay, so anyway, you do that, and that will create kind of our objects.pickle file, right? And so we have objects.pickle, and again, if you try to open this, this is again completely unintelligible, right? So I mean, you can kind of see hello world, but everything else can't really make sense of it. And you're not supposed to. You're not. It's not intended to. Okay. And so anyway, store it as a pickle file, and then later on, when you want to retrieve that, you can just do open it, right? So you do open the pickle file. We're going to read from binary mode, okay, and then we're going to call pickle.load. Pickle.load is going to then open that up, and we just unpack it into objects x1, x2, and x3. Okay, so we had objects 0, 1, and 2. We're going to tuple unpack to x1, x2, x3, and we can see x1 indeed is that list, x2 is this list, x3 is this string. Okay, and so you know, what can you pickle, what can't be pickled? You can read this documentation here. Okay, and so so lots of stuff can be pickled and unpickled in Python, and this is just kind of a handy way to kind of transport objects that you've created in one notebook to another notebook without having to like go through the process of recreating it. So if you've done some work and you've got a whole bunch of values that you want to save in some kind of object, probably the way to go in Python is to pickle them, or you can save them into a DBM if they're string type objects. Okay, a little bit shorter lecture today. We'll just end a little bit early and we'll call it a day. Let me give you your last view quiz answer. Last view quiz answer today is B as in bear. B as in bear. Okay, and we will end here. And have a good weekend, you guys, and we will see you guys on Monday.